now that we have learned the formal definition of what a permutation is, remember, big idea, a permutation is how many ways to arrange a certain amount of objects chosen from a total amount of objects. And remember, for a permutation, if we go back to the previous couple pages, a permutation is an arrangement in which order matters. Those are the key things to keep in the back of your mind. So let's look at some arrangements with letter orders. So perhaps the most commonly asked questions requiring the use of permutation involve letter arrangements. Many more problems can be solved by modeling the situation as an arrangement of letters. And these are, common in competition problems. Some problems that are not quite as obvious also can use permutations as a strategy. So it's a really good strategy to understand and have it in your background information. So first question, how many different 5-letter words can be formed by rearranging the letters in beast? For the sake of this argument, I'm just going to write the word backwards. We're going to assume that beast spelled backwards is a word, and any arrangement of the 5 letters is a word. So we're just going to accept pretend words in this scenario, is generally the expectation. So 5-letter words, there are 5 choices for the first letter, 4 for the second, 3, 2, 1, or 5 factorial. If you do 5 factorial on your calculator, just going to pull it up real quick, 5, go to math, arrow over to probability, and factorial is the 4th option on my calculator, and it's 120. Second one, how many different 7-letter words can be formed by rearranging the letters in algebra? So you might think that 1, 2, 3, 4, 5, 6, 7, that you would do 7 factorial. However, since there are 2 A's in algebra, we call one A1 and the other A2. Under our system, this word and this word are considered 2 different words, even though it's really the same thing. So, is there a quick way that you can think of to adjust for the overcounting that we have done? You might be thinking that we've counted each of these same words twice, so divide by 2. You are completely correct. One thing I do want to point out is it's technically dividing by 2 factorial, because that's the number of ways to arrange 2 things. I only want to point this out because if you had 3 objects, like 1, 2, 3, it's not that you are counting each time where you do like that versus this. You're not counting them 3 times, you're actually counting it 3 factorial, which is 6 times, because that's the number of different ways you can arrange 3 distinct objects. So I just want to point that out. A lot of people will jump to, oh, you're just double counting or triple counting, but it's actually a little bit more complicated than that. So that is the last problem. This one is just kind of a more complex version. So this is the end of our video on permutations, and the practice problems that follow on the next page, we're going to do those tomorrow during class. This last problem, if you thought this Algebra 1 is interesting, in our next video we're going to be looking at permutations with restrictions, where there's a little bit more complexity going on. So we're going to be picking it up on page 106 in the next video. I'll see you guys there.